Hello everyone, we'll start in around 5 minutes when more participants join. Is my voice perfectly clear or is there any disturbance? You can just type in the chat. Perfect, thanks. The attendance link will be shared at the end of the session. Okay, then let's start. So hello everyone, I'm Aditya Palve from Programming Club IIT Madras. We'll be covering unary operators, their overloading and functors today. So this is our agenda for today. I'll be covering a bunch of unary operators. Then I'll be explaining one or two of them in detail. Then we'll see how to overload them. And then we'll go on to functors. We'll learn what functors are. It's a new concept. So like any other operation, like addition, subtraction, division, they require two operands, like 1 plus 2, 1 and 2. They are different operands. So for unary operators, we need only one operand on which the operator acts and modifies the operand itself. So now we have around 6 unary operators here. The first one is unary minus, which just changes the sign of a variable. Like when you actually save, like say int b equal to -3, you're actually applying the unary minus operator on value 3, which converts it to -3 and stores it in the variable b. Then there is the increment operator, which adds 1 to the value. It works on integers, floats, doubles, and all of that. It actually works on characters as well. Like for example, it adds 1 to their ASCII value. If you have B and you do B++, you will get C, like small b to small c. Similarly, we have decrement, which subtracts 1 from the value. Then we have the not operator. In logical, in Boolean, there are true and false. By using the not operator, you can switch from true to false and from false to true. It's really useful in logical statements. Then obviously we have address of, it is not unknown to you. We covered it in the first and second sessions. It returns the address of a variable in pointers and stores it in a pointer. It is important when you want to pass an address of a point variable into a function, for example swap. Then this is something new, size of. It returns the size of data type in bytes. For simple data types, it returns the size of data types. For example, for integer, it will return 4. But if you have an array, like if you have int ar 10, so there are 10 integers in the array. So when you call size of, it will actually return 40. So by using this operator, we can actually find the length of an array. So that's all. Now we will look at the increment operator in some detail. So the unary increment operator is of two types, prefix and postfix. What do they really mean? Let's see. So first we'll look at prefix. So as you can see, the plus plus is present at the left hand side of A, which means we'll be first incrementing the value of A, storing it in A, and then we'll execute what the command is according to this preference order. So as you can see, now if we try to see out A, since the value of A was increased first, it would be 11 and then it would be stored in B. So when you try to output A, you will get 11. And similarly, when you try to output B, you will also get 11. On the contrary, we have postfix. So first we'll be executing the command, which is storing the value of A in B. So the value in B would be 10. And after the storing is done, we'll increment the value of A by 1. So which will be 11. So as you can see, when we try to output A and B, we get 11 as the output of A and 10 of B. So there are some different applications of this. One application, like this is the process is similar for decrement as well. One application would be using while in bracket t minus minus. You will see it mostly in code forces, like the number of test cases. If any of you guys do CP, so there we use while t minus minus, so that the loop is exactly run t times. In the place if you use while minus minus t, the loop will be run one less time, because first the value of t would be decremented and then it will go into the loop. So this is a subtlety which comes with the postfix and prefix. And yes, as I mentioned, similar for the decrement operator as well. So here is a simple question, I believe. The Slido QR is provided. and I'll just activate it. I'll wait for 2 minutes for this. Okay, then it's pretty clear that 80 would be the correct answer. I'll just explain it why that's true. So initially it's given that the value of a is 7. Then on this line, we do a plus plus. There is not really any expression to be evaluated. So the value of a will be incremented by 1. Hence it will be 8. And then we go on to the next line. Now here's the catch. There is some slightly complicated expression here. So we'll go from left to right. As we know, the value of a is 8. So value of in the expression, like for the product, one operand would be 8. 8 will be given as one operand in the product, and then the value of a will be incremented to 9. So now what we have is we have something of the type 8 multiplied by something. We are yet to figure out what the other thing is, and the value of a is 9. Now in the second operand, the value of a would be incremented first, hence it would become 10. Now this 10 would go as a second operand in multiplication. So the final multiplication would be 8 into 10, which would be 80, and the output would be 80. So this is really how the correct answer would be 80, and many of you guessed it correct. Many of you got it correctly. So it's really great you're understanding stuff. So we'll go to the next slide. Now the fun part begins. This is slightly tough, but as we progress in the sessions, the content is going to get a little tougher. So I hope I explained it well and you guys can keep up. I have used a slightly different notation for the constructors as of the last session. There I manually and like stored the value of C and 0 in the count variable. But here, let me explain this shorthand syntax once. So this counter, these are the function name and the parameter list. Since it is a constructor, we don't really need a return type, only the class name suffices. Then a colon, which is the shorthand operator, and then the variable is given here, and in bracket is the value which should be entered in, stored into the variable as per the constructor does. In the first one, the value is 0 is stored into count, and when while calling an object while making an object, if the user decides to enter a value, we call it C here, it is stored in the count variable. And the brackets are empty because we have no need to print anything. If it were needed, we would put some lines of code in there. Then our regular get count function. So here is a small thing, a small keyword I've used here, const, which means that the I don't really change any of the data members of the object in this get count function, which is pretty obvious because we are just returning the value of count and we don't want anyone to change the value of count. That's the whole reason of having a public get count function like this. So const, it does not do anything, but it's like just telling the viewer that the programmer means to not change any of the variables inside variables of the object by using this function. And then we return the value of count. It is for safety, as we discussed in the last lecture. So now here we have two different statements for overloading the operator. As we discussed in last session, the syntax of overloading any operator, it would be return type, then the keyword operator, which tells the compiler that we intend to overload the given operator. Then this is the operator we need to overload, and we take in any operand. Like for binary, since this overloading process is happening inside the counter class, the first operand, which is the operand on which we are, which is the object on which we are calling the operator itself. So we need not have any other operand, and hence the parameter list is empty. Similarly, while overloading for binary operators, the parameter list contain only one operand, which is one less than the total number needed. So one less than one is 0, hence there is nothing here. Now, to tell the compiler that we first intend to overload the prefix increment, we have nothing inside this. We return counter plus plus count. So this is a kind of, we shortened the code of forming a temporary object. I'll come to this later. It's explained in just the next slide. It is known as temporary nameless object. Then I have written the syntax for overloading the postfix operator. To tell the compiler that we want to overload the postfix operator, we just need to write the int, which is the data type of the variable inside the object which for which we are uh, having the overload statement. So these two basically do the same thing. There's a subtle difference of the int in one place, and then we have the private int count. So this ensures working of both statements. C2 is equal to plus plus C1, C2 is equal to C1 plus plus, and the bottom ones. So I'll try to explain in depth the ensures part. So, and normally we can just have something like plus plus C1 or C1 plus plus. For example, we had here A plus plus. So it didn't really return a value. It need not return a value. Even if it does, we have no problem with that. But if we have something like If we have something like void operator plus plus, so if I call a statement like c1 plus plus or plus plus c1, it will not return anything. It will just increase the value of count variable by 1. But if I have statements like these, c2 equal to plus plus c1, it will raise an error. So to remove this error, I need to return an object of the class counter. Hence, we have this return type counter that ensures that both these statements work. So that's the reason of having return type counter. Now we'll go on to the next slide. Now the concept of a temporary nameless object. So like in previous session, I had int c equal to plus plus count counter temp c. So temporary, this is a temporary object of the counter class, and then I return it. So it was really typing 3 lines of code. However, now I can just do the same stuff in only 1 line. Return counter in bracket plus plus count. Because the C is plus plus count, I can directly put it here. As it is anyways incrementing the value of count by 1. So we are getting the same functionality here. So these two statements essentially do the same thing. Second one is preferable because we have to type less. So I think I'll wait for 1 or 2 minutes. If you guys have any doubts, I'll just look at the chat here. If you have any doubts, okay. Perfect. I guess it's answered. Now, okay, cool. If you have any doubts of whatever is covered till now, you can just type in CodeCrafts Slido or in the chat here. I'll be answering for 1 or 2 minutes and then I'll proceed. Can't get why there is problem or it will occur if we use plus plus with C1 and C2. Okay. So I'll try to type something. For statements like A++, or in our case, it would be C1++, I can just overload the plus plus operator to be void operator keyword, then increment in bracket. I'll put in because I intend to overload for the postfix. Return, no return actually, count plus plus. Perfect. So by having this syntax, I am actually increasing the count of C1 by 1. Note that the definition of this would fall in the class counter. Hence, I don't really need to specify the count variable is for which object. It is by default for C1. So now there would be no problem here. But the moment when I have an expression like C1 equal to sorry, C2 equal to C1 plus plus, this will throw an error because the return type of this is void. So it is not really returning anything, but we intend to store the return stuff in C2. So there would be an error by the compiler. So to counter this error, I just change the return type to be counter. I do some stuff here and I return the temporary object. So that stuff would be return counter count plus plus. Perfect. I hope it would be clear for you. Okay, then we have waited enough. I'll proceed. So now here is one more commonly used operator. It is known as the subscript operator. It is mostly seen in arrays, vectors, and strings. We use it to get the value at a specific subscript of an array or a string. So, yes, one more thing. We not only use it to get the value, but we can also modify the value if required. So, for example, if you have an array 100 and arr at subscript 1 is 3, I can just change arr at subscript 1 to be 5, and it would be perfectly fine. It is meant to be that way. So, one more thing for arrays and strings, the address, this arr, the value in arr, only arr, is a pointer which points to the first location in memory where the array is stored. So that's why and arr, like the address of arr and arr is the same thing, because arr is the reference itself. Now, to access something 5 positions beyond the first element of the array, we can do something like star in bracket arr plus 5. So I'll just explain this. So by plus 5, we increment the value of pointer by 5, so that earlier arr used to point to the 0th element. Now arr plus 5 will point to the 5th element, and I dereference it. So instead of writing this long stuff, I just write it as arr subscript 5. So this is the same thing. This thing which you actually use in CP or in normal coding is the short form for this. And this is more general. You can access negative values for pointers, or you can go beyond the limits of the array, but it is not advisable, but you can do it. Okay, then. So we'll try to overload this operator. Perfect. So let me explain this code. So here I have a class S array. S stands for safe array. Now in which I won't allow, I will like exit the program the moment, if the moment the user tries to uh, uh, input any wrong value in the subscript. Now we'll just jump to the if statement, ignore the stuff. If n, the n which should be inside the subscript used by the user, if it is less than 0, like if it's negative, or if it's greater than limit, limit is the max, this length, if it is greater than or equal to length, we'll see out index out of bounds and we'll exit the program immediately. Exit one stops everything and exits the program. So for this, I have a constant limit equal to 100, which is like the a constant integer, which says the maximum length of the array. I have int arr limit. If I have to change the length of an array, I'll change the constant here. So for every object of the class S array, the only private data member would be an array having the limit number of elements. Okay, then. And this is the overload statement. So here you can see we have a return type, but there is a small subtlety. There is a and address operator. So what does it do? We'll discuss it one slide later. Then the operator, then the operator keyword, then operator, then the int in n, which is the parameter, because this is kind of a binary operator. We require the name of the array, and there is a value inside the subscripts in the square brackets. And if it does not cause any problem, we just return the value present at the nth index. So this is what a small class S array will do. Okay, then now we are understanding the overloaded operator. Int at the rate returns by reference. Since we just don't want to return the value present at index n, but we want to give the user the privilege to modify the value if required. Hence we return the reference. Now that we have returned the reference, when the user tries to modify it in his own code, like for us it would be the int main function, it will be modified in the memory as well. Just like in arrays, you can do in arrays, vectors or strings, you can have like ar5, ar subscript 5 equal to 10, which changes it from, suppose it's 0 initially, it changes it from 0 to 10. So this, for the same functionality, we need to add the ampersand here. Then the exit one ends the program since the user requested for incorrect index, as I explained earlier, and this if statement is pretty clear. Okay, then I'll just show a live example for this, what I mean to do with this. Suppose I have defined that class, I won't really type it out. I'll just type the required syntax. Now that we have defined obj, obj dot ar would be an array. Although, since it was declared to be private, we cannot really access this here. We cannot really dereference it here or use, yes, we cannot really use it there, the dereference operator, because we don't have access to this. So instead, we have to use this subscripts like this, since we have declared the subscript in public. Perfect. So as we know, the length would be 100. So if I put something like -4, this will cause an error. Like there would be something printed, index out of bounds, and the code will exit. Similarly, if I put something like 105, there will be the same printed index out of bounds and the code will be ended at that moment. But what if I put something like 10? Then there would be no issue and I can actually see out. Now here there won't be any value and I won't run because I haven't written the class code. We can just see out it, we can get the value present there, or we can change it like this. Actually, I'm so sorry, but I will have to do like this object because we have overloaded it. So first it was obj -4 error, 105, once again error, 10. I'll get the value here, and this I can just change the value from whatever it was to 10. So this is the functionality we get from overloading the brackets, the square brackets. So if any doubts, I can just open this. We can't really return the arr because arr is a pointer, and the main functionality of having a subscript is we need to return the value present at that subscript. As I said earlier, the arr would be an address and we don't really care for addresses. That's why. Okay, then I'll proceed. However, free, there would be the process of overloading operators. We can do anything, but we try to keep it logical. There are still some operators which cannot be overloaded. If you try to overload them, the compiler will throw an error. So I don't really know the reason why they can't be overloaded, but it's predefined by the language itself. So these are the 5 operators. Scope resolution operator, you will use it in inheritance, or you have also seen it when you declare a function prototype inside a class and you have the actual function definition outside. There you need to use the scope resolution operator. You'll see it soon enough. And the ternary or conditional operator, it's for logical statements. So it's a syntax to shorten the if-else block. I don't know if you have seen it, but it's some cool stuff. The member access or dot operator, we have seen this a lot while accessing data members from objects if they are public. Then pointer to member operator. So this has a pointer to a data member inside object. It's really complex stuff which you won't come across for some time. And this size of operator. Now we have seen the size of operator now only some time back. Any attempt to overload this operators will result in an error. Perfect. So we'll proceed. Now we come on to functors. Functors is some cool stuff. So just a minute, I'll drink some water and we'll start. Awesome. So functors it is. Functors, also known as function objects, are objects which can be treated as if they were functions. Sometimes there may be need to send in a lot of data into a function from the argument list, but due to keep the length of the code short or for some other reasons, there would be less number of arguments the function can actually take. So in that case, you pass an object as a function inside, which can help you to give in more data. So it is something we'll try to see. Not really, but you can do it. It's one of the advantages of using functors. So functors basically involves overloading the parenthesis, so that when parentheses are used with an object name, a function is called. So I'll just explain the code in a while. But here, as you can see, add5 is the name of an object of the add functor class. But when we use add5 with parenthesis, it behaves as a function and actually returns a value which gets stored in the result. Note that here, when we are actually making an object of the add functor class, this 5, it's for the constructor, and the overloaded parentheses don't act here. So what this example means to do is we want to add some value into a given variable here. So for sometime call this, remove this 5 and think as if there is a variable a present there, and instead of 10 there is b present there. So a and b can be some random integers. So what I do is create an object of the add functor class with a private integer value. This value will have the value a. Note that a is present in place of 5. So value would be a. Then when I call the overloaded operator in bracket like we do here, so we have the object name, and since we use parentheses, this overloaded statement, which is actually a function, is being called. It takes an parameter. Takes a parameter which is b, and it returns a plus b. So this is what we aim to achieve from functors. It is slightly complex, but try to understand. So we look at an application of functor in the transform algorithm. So before we look at how functor is used, let's look at what is transform first. So transform is a inbuilt function in the header files, which takes in a container. Here, a container is anything like array, string, vector, map, set, which are a set of different data types stored in a specific way for some advanced functionalities. So for further examples, I'll use array because it's by far the simplest container I could think of. Perfect. Then we have an iterator, like in case of array, when, for example, some of you might have used the sort function for an array. So in the syntax goes like sort in bracket r comma r plus n. So in this case, r is the iterator input begin and r plus n would be the iterator input end. Similarly, for vectors, to get the iterator, we have to write vector name dot begin, and for in output, we have to write vector name dot end. So this is the case. This is what iterator is. It takes the transform function would take four parameters. The first parameter would be the first iterator of the input container. The second would be end iterator of the input container. So till now we have the data set on which we have to perform something upon. Perfect. Then the third would be iterator output begin. So after we perform the operation on the given data set, we have to store the result. The result is stored in contiguous, like in the new array, whose first iterator is given by output begin. Now you can see, suppose if we want to do something on an array R and store the same thing in R itself. So we will have to, we should put the first and the third parameter as R itself. So this is shown here. And then the fourth is unary operation. So what transform does is it gets a unary operation as the fourth parameter. It has a input data set. It performs the operation on every element in the input data set one by one and stores the result in the output data set, output iterator one by one. That's why all the four parameters are required. Now we'll look at an example of transform. Okay. So we aren't going to see functors here. We are going to see an example of transform without functors, and then we'll see how functors make the code better for us. We can have some more functionality in that, in the transform function. So now I just have a simple function by the name triple. It takes an integer x as a parameter and returns thrice the value of x. Perfect. Now we have an integer array with the values of 1, 2, 3, 4, 5. Note that we have seen size of here. So size of r would be 5 into 4 divided by size of a single integer, which would be 4. So we get n as the length of the array, which would be 5. Perfect. Now we call in the transform. The first parameter was an iterator, which would point to this 1. The second parameter would be an iterator r plus n, which would be r plus 5, which would point to this 5. Sorry, which would point to one element next to 5. So when the transform function runs, it runs from the input the first iterator to last but one, like it runs to the second last iterator. So the transform will run the function triple one by one on every element in array from 1 to 5, and then it will store the output of every element in R itself. So the result would be, it will triple 1 and place it in the same position as 1. So the final array which we get after running the transform would be 3, 6, 9, 12, and 15. Now we just print it and we return 0. And just wait for a minute and see if you have any doubts. What's the use of iterator end? added to calculate for each and every element of array. I don't really understand what you mean. So I'll just explain what we did with the transform function. I'll show with an example. Suppose I define an array to be so the length of array is 6. Now when I send into transform, so when I send in r, it will be an iterator which points to this 1. So r points to 1. Then, for example, if I want to send r plus 3, this r plus 3 will point to r, r plus 1, r plus 2, r plus 3. So, but how the function is designed, it performs the operation on the or from the initial to the second last, which means it will perform on 1, on 2, and on 3, but not 4. So it will perform on 1, 2, and 3, but not 4. Cool. And then we'll have r. When we get the result, it will be again stored in r itself. Perfect. And we send in some function. Suppose now I'll just show some example itself. Now I've come too far. Perfect. So as you can see, I've had defined a function increment which takes an integer x and returns x plus 1. Since it takes only one parameter, we can safely call it to be a unary function, and we send in as the fourth operand, fourth parameter. Then we send in the first iterator, the end iterator, so it will run to 1 less than the end iterator. So in this case, we see that the modification have been done to 1, 2, 3, which have been turned to 2, 3, and 4, and stored back in the array itself, so that r is changed. Suppose if I have some different int br int brr3. Now, if you see, and I try to run it, Now, since I changed the output container, the values were stored in some random array known as BRR. I don't really care. So as you can see, the array was unharmed. It was unchanged. So this is how transform works. I guess it's pretty clear. I'll just check if there are any doubts. Is it? Okay, then I'll come back to it later if it's not clear. So let's see how it's done using functors. Since in the previous example, we used something triple, which really streamlined our scope, our functionality was to be multiplied by 3 only. So now I define a general function known as multiply. So for that we need, since we are using functors which are objects of a class, so first I'll need to define a class which I call to be multiply, which has a private integer num. Then I'll have multiply int n. It's a constructor which initializes the parameter n give while calling the constructor into the private data member num. And then I overload this parentheses and I take in another parameter while calling the function with the parentheses, like while calling the functor, and I return their product. So you can see it's a functor. And one more thing, here also I've used the const keyword because I promise that the private data member num was unharmed while having the function, while having the overloaded parentheses operation. Perfect. So now I'll show you how it's used. So we declare an array, we get n as its length, which would be 5. Then I have a general integer x. The x is the multiplying factor. So for this case, I'll assign 5 to x. Then the similar for the first 3 parameters of transform. But in the fourth parameter, I just have an object. See, since multiply is a class and in this is a constructor multiply and an integer in the parameter list. So multiply in bracket x would be an object. So I'm passing an object. Cool. And perfect. So I'm passing in an object. Oh shit. Sorry. Slightly different. So in this case, I am passing the pointer. Now, previous I did not tell you, but the fourth one is a function pointer. We call it function pointers. So here we are passing the multiply as a functor, which is an object which works like a function. So it takes input, like for every element in array, an object is created of the class multiply, which has the value like 1 2 3 4 5 as its num, and then it is multiplied by this x, this here int arr num, which would be x in this case. So it's slightly confusing syntax, but just understand that multiply by x, this is how you need to understand it. And when we output arr, we get 5 10 15 20 25. Now the better functionality we have here is that I can just change x and I'll have many types of desired outputs, or I can just change the definition of operator here, and I can have any kind of operation I need to be done, any kind of parameterized operation. Like here multiply is the operation and multiply by what, it's the what is the parameter. This case it's x, which is 5, the parameterized multiplication. Passing temporary nameless object of class multiply as a unary function. Perfect. So these are the attendance QR and the feedback form. Please fill it. Then this I'll just iterate through what all we covered today. We saw 6 unary operators. One would be increment. We saw the prefix and postfix for increment. Then we saw how to overload. The process of overloading for decrement would be same as it was for overloading the increment operators. In this, we saw overloading of increment, the subscript, the parentheses, and then we saw a small example of using functors. For functors, one application was using in the transform algorithm, which aims to apply a specific change to every element in a given container. Containers are nothing but arrays, strings, vectors, sets, maps. I'll also request you to give me some rating on this rating poll, which I've started on the Slido. The Slido link would be available on WhatsApp, or I've shared the QR before. If any doubts, I'd be there for more 15 to 20 minutes, and you can just ask it here. If you have any doubts, I'm here for more 10 to 15 minutes. You can just send them in the Teams chat or CodeCrafts Q&A. Is your doubt answered, or should I talk something on it? Just say yes or no. Just type yes or no, sorry. Perfect. So how to remember the syntax for so many declarations statements? I get stuck remembering the order, type of brackets, etc. So once you start coding on a regular basis, once you start using the operators, using the different types of overloading, if you can find various websites on which you can practice codes, or there are various books, then it just fits in your head. Like once it fits in your, like, you don't need to rote learn it or read it again and again. Once you use it for 5 to 10 times, it gets stuck in your head. You can just think it, what do you say, intuitively. What's the last date of mini project one submit? It would be 18th July, 9 p.m. You're welcome. I'll actually get back to you on which books you should refer to. But I'll say rather than books, you can find a lot of online resources. You can just type the topic which you need and you will get some 2 to 3 articles. For example, if I just type in functors in C++, I get a loads of websites on which I can learn stuff. Stack Overflow is a really cool site to learn, to dive deeper into concepts of coding. Perfect. No, there's not really any homework. After we finish the mini project 1, on the same day itself, we'll release mini project 2. It would be slightly difficult than mini project 1 because now you are slightly more accustomed to coding, and we request you to put in efforts, and like it's the right way to learn. Then you must need to search stuff on Google. It would be almost like 80% is covered in the sessions, 20% you have to look through yourself, because the main aim of this session is to improve the coding in open source community. For open source, most of the stuff you have to learn by yourself from Google, from man pages, document official documentations, etc. So we, in order to encourage that, the 20% stuff you have to learn from yourself. Just in case any of you miss the QRs. Okay, then I'll end the meet. Thank you for attending. I hope you don't have any more doubts. If you have any doubts, you can just DM any of the admins on the CodeCrafts group. Thank you for attending. Bye bye.